All right. Good evening, everyone. If you're watching this live, it looks like there might be one of you. Thanks for joining in. Feel free to leave a comment. If you're watching this in the future, today we're going to be finishing up the Titan 1M that we made last week. Um, so this is the part. This is how it came off the mill last time. And again, we were using a drill that was too small and kind of just a general drill bit. It wasn't necessarily made for machining. But the drill held up pretty well. The tap did pretty good. So the second op of this should be pretty simple, but when I've made this in the past at like a makerspace place, this is always the part that I seem to have trouble with for some reason. But basically, just an overview of what we're going to be doing. We're just going to be taking the face mill and taking off this top layer, removing this excess stock. Sometimes they call it like carrier stock. It's what you use to hold the material in the vise. We're going to be taking that off, and then we're going to be adding a nice chamfer like this. So, yeah, let's get right to it. We're going to start in the programming mode. Okay, so here's the video. This one's only 9 minutes, not 45 minutes. I think this one's made with Haas, not with Tormach. So we might have to adapt it a little
Hey,
bit.
what's up, everybody? This is Titan from Titans of CNC, and today I'm going to teach you how to program the second side of the Titan 1M building block. All right, so on the first side, we faced the top, we profiled, we did the pocket, we chamfered, drilled, and tapped, but we left 230 thousandths, 0.230 of stock on the bottom. Okay, so there's a few different ways to do this. What I wanted to do was actually make
I'm
it
just gonna
clean.
stop for a
So
second.
I
He
just
said we
wanted
left
to come up
230
here.
thou on the bottom. I'm just gonna measure it real quick, see what we get. So I'm only seeing I'm getting 0.199, so 199 thou. But maybe the actual part I'm getting 0.97 there. All right, sorry for the interruption.
I
Okay,
resaved
do
it
that.
as B, so I made it a completely
So we're gonna
different
save
model.
as Titan 1M up to live stream. Don't save it under the mouse case, save it. Okay.
Saved it as B, so we still have our A setup separately. Okay, so now this is B, so I just saved it. So now we're just going to go through the entire process again, but now just with two tools. Nice and easy.
Let me go ahead
Okay,
and
so
delete
we're
the
going to
old
hit
setup.
setup. Boom. All right, now we're doing the opposite side. Because we're upper left, I'm just going to keep it upper left. Okay, there's no holes or features on the second side, so it's nice and clean. All right, so I'm going to come up here. I'm going to hit this guy, Z and X. I'm going to hit Z. I'm going to hit X.
Okay, so put this on it quite. I'm just gonna go back. Keep click.
Hit Z.
Be this corner. C X will be this. Boom.
I'm going to hit X. Boom. Turn that guy around.
Bit.
And then I'm going
Okay.
to come over here. I'm actually going to say model box point. Click this guy. Click it a second time. Boom. That's where I want to be.
Oh, hold
So
up.
now let's actually put our
So he's
stock
got the
where it
back
needs to be.
corner.
So I'm going to come over here. So
Box
next
point.
you're going to say model box point. Click this guy, click it a second time.
Why do you have to click it a second time?
Boom. That's where I want to be. So now let's actually put our stock where it needs to be. So I'm going to come over here, stock on all.
One times. Probably picked the axes. Let's go Z there, X there, box point there. Okay.
On all sides. Boom. I know that there's 50 thousandths around, so I'm going to go.
Again, I'm going to
50.
measure this. So, hey, what's up? I'm guessing I must be Jacob. Probably shouldn't be typing the responses to comments, but hey, what's up? Thanks for checking out the stream. Okay. So he's saying there's 50 on each side.
50.
I want to get the total length again. Getting 4.1835. And our model was what? 4 inches, right? So minus 4. Let's say it's on evenly on both sides. And that was a terrible saw cut. So I got 9.09175. Add stock to all sides. 09 and 175. This is probably where I'm gonna get some issues. I think we kept
50.
this at 50.
50. Now, I'm actually going to come down here. Watch this, 0.23. So that's how much stock we have, right? And you can see the material that drops all the way down. And I really don't
noticed these
care about
comments
that,
earlier
but just to be
talking about just set the Z0 on top of the part. When you machine it, get the Z from the parallels. So I think this is what they're talking about. So I'd basically be putting the part in here and measuring with the calipers down to the parallels. And if we're measuring from this top of the part, that's actually our model top. So it kind of makes sense. We'll come back to this. For now, I'm just going to put in what he says. That's 0.23, he said, right? Okay. So that is what it looks like. So, okay, so if we're using model box point, yeah, I like the idea of the comment there. I think that's a good idea, and I think this is how to execute it. Box point. I don't know why he said click it twice, but okay, so now this is going to be sitting on the parallels. And if we can measure with the calipers up, what is it, 0.75? Or he said, what, 0.76, right? We'll make it 0.7. Can't find that one sheet of the drawing that I need, apparently. Well, at least the first block one here says 0.750. So we're going to, we got the actual top of the model, as we would normally call it, the top selected. So yeah, I think we're just going to leave the stock like it is and then go on. I'm using a 1.5 inch. $4,000. Probably do 20 inches a minute. I'm still gonna do 20. What did he put in 100? The plunge. That seems risky. Okay. He knows better than. I don't trust it. He didn't select anything on this page, did he? This is where it's going to get tricky with the changes that I made. Okay, so all of these are going to be model top. Model top. Okay, so he put clearance height at 1 inch. I don't think that's going to be high enough. Oh, no, it's. I wonder where it's measuring that from. 0.75, so it's 1 inch over the bottom. Okay, okay. Retract height. Inch. We don't want 1.7 because we only have a 1.5 inch. I'm just gonna go back to the old one. Oh shoot. Ah. Well, let's start that one over. I hit undo instead of save. And I don't get the redo button. So face. Of course it doesn't remember anything. Okay, so 4,000. 20 inches. I just did 20 for all these. Geometry, nothing. Heights. Okay, this was probably worth double checking what he did. It was 1 inch, 1 inch. This one was 1 inch. This one was 1 inch, half an inch, 0.23, 0. S's. Okay, this is where we were. I'm just gonna hit OK for now. And extension. Edit that. He's using 1.7. I think we want just a little more than half, right? but let's do what I was going to do earlier. Open up the, hey, what's up, John? This part doesn't do anything besides teach me how to make parts. So it's purely just an educational series that the Titans of CNC Academy puts out just to like help people learn this trade basically. Like he's all about American manufacturing and he puts this stuff out here. His proprietary statement here even says that you have the right to copy and share all materials herein in any medium or format. You may not use materials for commercial purposes. You may not modify or redistribute modified materials. And yeah, so it's pretty cool. Like I think they don't mind that I'm doing this. Not like I'm really threatening them in any way by doing this. They're much more established and yeah. Anyways, yeah, no real functional purpose for this block besides just training and education. So we are going to go back to our op1. Just look at what we used for that facing tool. Yeah, it was all 20 inches per minute there. So we use 0.76 inch pass extension and 1.4 inch step over. Point 0.76. 1.4. Right, now let's see if that actually saved it without me saving it. Bet it did not. Look at that, it did. 0.76, 1.4. Now I probably have to leave some stock. I hope it will on the Tormach. No problem, John. Thanks for coming out and watching. I appreciate it. Let's see. Finishing step. $5,000. I'm just gonna leave that. Simulate that. In process, stock is missing. Stock might be. I'm gonna do a 2D chamfer. Boom. Still gonna keep it at 20. This is the part that's gonna be trickier. Oh, I do need to select a contour. That would be helpful. Matt Justice, thanks for checking it out. Joseph Brinken. How's it been, man? So many people I haven't talked to in a long time. It's awesome to see you guys coming in here and watching. All right, I'm kind of got distracted there. I'm reading the so model top 4 point. Okay. Whoa. That, yeah, that's right. And no. Gonna lead in 0.1 hundred thou. Right, so there was something here that we didn't quite get. 50 thou. Okay. Chamfer width is not. Oh, it's because there's a 0 in there. That's why it's messing with my brain. Brain fart. 50 thou tip offset, 10 thou chamfer width. You put a chamfer clearance in there. Diesel thing on here. So we'll leave that at 0. Okay. I think this should about do it. Simulate that one. Really quick. That's really slow. The offset of the tip. Yeah, Joe. So we're doing the cam right now. So we're using Fusion 360's computer aided manufacturing. And so this is just going to post process all of the G code for us, which is really convenient. You don't have to actually program G code, even though I would like to learn enough to at least be able to read. We're in setup to number 1 and 2. You know what? I don't like that though, because it's actually tool numbers for me. And I would rather actually, what did I do? All right. I just want to renumber this one to 3. Just for my brain to not have to mess that up, even though I'm sure it would be very obvious if I was putting an end mill in there instead of the chamfer tool, but 3, let's simulate the whole thing. It's going a little faster than his is. All right. Looks good. So I think we're ready to post-process it. We're going to post-process this Titan 1M op 2. I do have Smart Cool, but I don't know how to use it or ensure that it actually works right. The right folder, post it. Boom. Should open up. Sure that this doesn't start auto playing any videos. Oh. Yeah. How long was I in that view? Hopefully you've been able to see the screen for a while. You just didn't hear me talking. Interesting. Okay, so we can close that out for now. Go to full screen here and pull up the code. I think from what I've heard, this is like a safety line. It kind of cancels any programs that might have been like interrupted midway. This is tool 1. I don't know enough about G-code yet to explain all this, but this is S4000, that's your spindle speed. M3 turns on the spindle. M8 turns the coolant on, and P0, I think that's something to do with the smart cool, but I don't know. But all we really need to do with this is put it on a flash drive and get it on the computer. So that is here. Right. So, them op 2, put USB under format. All right, so that is on here, and we are going to go to the machine. So this is hopefully the more exciting part. It's definitely where I'm more likely to make egregious errors. Just gonna plug in the USB. Hopefully you can still hear me. Yeah, that's looking good. I'm gonna print off a setup sheet while I'm thinking about it. All right. Bad boy off. Hopefully this doesn't take too long to pull off the printer. It's receiving data. Basically what I want this setup sheet for is to check the minimum Z depth, which is supposed to mean something to me. I think I might know what it means, but I'm not 100% sure. But the setup sheet says the minimum Z 0.69. So that makes sense because that's what we had, a 50 thou offset of the tip of the tool. And then our stock 4.14. Okay, so basically I think we need to take 92. Is that the numbers we came up with? Yeah, we'll round up to 92. Okay, so when we find our location with the tool finder, we need to take 92 thou off the side. So let's get our part. That would be important to finish it. Don't want to lose that. Okay, and we were supposed to use a stop last time, which would make this a little easier because I would have been able to like locate it against that part, and then where the actually runs up against the work stop would be like, no kidding, your model edge. But I wasn't prepared enough for that. And so we're just going to put this back in the hard jaws that we mangled last week, or on Saturday, I guess it was. Where's my mallet? Whack this thing. There it is. I don't know why I don't keep it on the little storage hook down here. I'm just going to tighten that. Okay. So we got that in there. Let's jog this over. We're going to use our edge finder again. I do have a probe, which I don't know how to use, and a Heimer probe, which is like a not digital version of a probe, which would be helpful, but I think we're going to try to use that on the next part, the Titan 2M. So let's get this spindle going. You know, it's been a while since I've had it running. I did kind of do a little warm up before, but okay, it went straight to 1,000. I thought I set 15 or 500. So I got this spinning at 1,500 RPM. What we're going to try to do now is get the X location, and This is going to be tricky because I had an absolutely terrible saw cut. So it's not exactly precise. It's not a machined edge that we're locating up against. So I'm just going to bring this in gently, gently. And I'm going to start jogging it in 1 thou increments. Okay, so there it stopped wobbling. There it's over wobbling, and I'm going to back it off about 3 clicks. I don't like that. There we go. Okay, so this should be, what did I say, 92 thou to the left of our model. So I'm going to hit 0x, and the diameter of that edge finder is 200 thou, so we're going to take half of that. And so we're going to be minus 0.192 in the x. And I'm just going to verify that real quick by backing off a little bit and bringing it back. Okay, so 0.192, perfect. It's exactly where I wanted it. Now let's go up. Still learning which way is which on this thing. If I turn it right, it goes in the positive direction. But the way you got to think of it, it's not, the doesn't move the way you think it does. As far as I understand it, the positive directions are relative to how the spindle is on the workpiece. So we had our X, Y, 0 at the model top over here. So if I move in the positive Y direction, this is a right-hand coordinate system, so this is X, Y, and Z. So positive Y is away from the machine, but positive Y on this dial will actually move the vise toward me because it'll move in the positive Y direction of the part. So it's kind of a little tricky to get the hang of. So I'm going to go negative here. And I went the wrong way. Alright, so this one I have a little mnemonic for, kind of like firefighting, where right... Oh, I have it backwards though. The firefighting mnemonic was for life, and I had this as right for life for some reason. I need to come up with a better mnemonic. Because moving right brings the spindle up, which is the safe direction. Alright, so this time I want to move the part in the negative Z. Okay, cool. Let's get it wobbling. Maybe a little too close. There we go. That's wobbling. Look past it and back. Okay, so 0 to Y. We're going to call this just 50 thou, I believe. So this is in the positive Y direction, so we're going to go positive 50. And now I'm going to stop the spindle, go to G30, which is our tool change. I'm actually going to hit feed hold here and set this as G30. Because for some reason when I hit G30 it moves the table and I don't want it to do that. So I just want it to move the spindle up. We got our X and Y located. And to check that, we can actually, I did use the taller parallel, so we hopefully won't be kissing our jaws again. Hopefully we don't throw the part. So this is going to be our test here. This is me trying to actually use G-code. So what is it? It's G00, which is a rapid move. And I want to, what the heck? I'm on main. G00. I hit spacebar and it just like disappears. What's up with that? Oh, it's because I was in the middle of cycling start. I'm using this to power my my GoPro, and it remembers that. Okay. Interesting. So let's go to the MDI G0. There we go. Space G00 is a rapid. I'm gonna go. We didn't do Z yet, so I gotta be careful. I'm just gonna go X0, Y0. And I think I need a G43 in there. That's like our absolute. But I think it remembers that. So if I go down, this should be like exactly on our model top, and it looks pretty close. Okay, so back to G, go to G30, which is our tool change position. Okay, and we're gonna set our Z height here. And this, it's gonna be tricky. I need to remember. Remember, this is where we needed to get the height from the parallels. So this is where if we're gonna mess it up, it's gonna be right about here. So let's just try that. So that is down to the parallels. I got 0.8865. 0.88. It's hard to be consistent with these things. They're not super accurate. Whoa. 0.997. Oh, wow. Good thing we checked. The part slid off the parallel. Wow. I haven't done that before. I think it's because I'm not used to a ratchet for a vice handle. I'm used to like a no kidding vice. So it's a little easier to like make small adjustments back and forth. Okay, so that is on the parallels. We'll get our mallet, smack it once. I've heard you don't need to smack it anymore. Tighten that down. Check that. Okay, so now we're getting 0.9725. That sounds about right. Yeah, we're going to go with that, 0.9725. But what does that number mean to me? 0.9725. So that is the distance . 0.9725 is the distance from the parallels to the back of the stock. So that means if I use my 1/4 thou thick paper and touch off this tool, come on, am I still in, yeah, still in this thou. There we go. So 0.9725 plus 1/4 thou. So we're going to zero this out, and we are going to be, I'm just going to write it out. I don't want to do the math in my head. 0.9725 plus 3, it's going to be 0.97, we're going plus 4 rather, so 0.9765. But I'm just going to let it do the math for me. Okay, so that worked out. So I think this is good because we're reading on the part 0.9765 is our Z height, and then our minimum Z. All right, our minimum Z was 0.69. So I'm going to go off to the side and go down to 0.69 and see what that looks like. That looks pretty close. And that's going to be with the chamfer tip, so this tool is not going to go that low. Actually, this tool only goes to 0.75. It tells us that. So let's see what that looks like. Yeah, that looks pretty good. So I'm feeling good. Now I'm going to load the code. Tormach Titan 1M, copy that over. Titan 1M op2. Okay, so we got that loaded. I want to go to G. With that low, I'm just going to jog it up just in case. It should always move the Z first and then X and Y. But yeah, like that. Oh, we lost the camera. What happened there? I think that would be a real shame. It's thinking, it's turning on. Okay, we got it. It's back. I think I have to like change the view thing somehow. Sorry about this. I want video. I think my trick for this is to unplug it and plug it back in. Sorry for the interruption. Once I get air conditioning in this shop, it should be a lot nicer, hopefully. There we go. Just gotta go over to there. Boom. Okay. We're good. So I'm gonna change my Z height. I want to go up 3 inches. So where we at now, if we think it's 1, here, let's actually just go to 1. We'll do a G0 Z2. We'll see where that puts us. I'm ready to stop it if I need to. Okay, so if this is 2, I want it to think that it's at, so I want to subtract 3 inches from this, right? We'll try that. And now I'm going to bring it up. And we'll do that same line again. Okay, so we're now 3 inches above our part. I'm going to hit cycle start. Oh, why does it not have a tool length? There we go. So this should go 3 inches over the part. Looks good. I'm too impatient, and this is just my education machine. So we're going to go ahead and add back 0.3 to that. And we're going to reset, and we're going to do it for real. So let's make some chips. That's a pretty hefty cut on the first pass. I hope it can handle that. It seems to be doing all right. It's just throwing chips on the side window. Crown chips on the front of the window now. That's pretty cool. So we're supposed to do this in 3 passes. So we'll see how that goes. That coolant's still not doing anything. I need to learn how to use that smart cool to point it where it needs to go. Wow. I mean, it's doing it. But we were doing, what, 80 thou per pass? That might be a little strong for the Tormach. You can hear it kind of bogging down a little bit. Maybe. Hopefully. So we should only be leaving about 5 thou if we did our measurements right. Let's see how that goes. This is our last roughing pass. I love that. It's just chucking those chips. I'm gonna turn the coolant off. It's not really doing anything anyways. Alright, so after this we should just kiss it and take 5 thous off. 5 thou off, rather. Just barely kiss it. The tiniest little chips are flying off. And this, I do want to put the coolant on if it'll hit it. Why is it inconsistent like that? Must not have been running long enough. Tiniest little chips. Alright, so that's the end of tool 1. Let's blow it off. That looks pretty good. I like that surface finish. So let's go ahead and swap that out. And here comes the part that's easy to mess up. The good news is, usually when you mess it up, you mess it up by like not hitting it enough, hopefully. But we're gonna take our rapids down to, we're gonna start at 10. Tool 3 is in there. I'm gonna turn the coolant off just so we can see better. Bump the rapid up just a little bit to get it to the start. Alright, don't want 0. There's 7% rapid. Oh, man, you guys should have warned me. Titans 991, 10 years. That's when I graduated high school. I don't know from the username who you are though, but thanks for coming. Safety glasses. Remind me if I'm ever not wearing those. Okay. So very slow rapids here. That looks about right. Could it be I'm actually getting it right? That looks good. I'm gonna leave the rapids low because this is a feed rate, so it shouldn't change it that much. Gonna hit it with a blast of coolant. Oops, not feed hold. So I gotta hit cycle start because I accidentally fat fingered the feed hold button. This is going really well. I'm liking this. If it wasn't for that mix up with the threads and the drills, this would have been so far so good. Maybe once I get thread gauges, we can actually see if I made this per the spec or not. Look at that, coming right around, finishing that back side up. And that should be it. I'm gonna go back to Mac Rapids. Okay. That's the first time it went the way I expected it. I think measuring the actual Z height, like those comments on the YouTube video, I think that helped. Because getting the right height was always the issue that I had before. Tool 3. Alright, let's get this thing out and take a look at it. And then, this, like I told you, this one was going to be quick, at least compared to the last one. All right. So here's what we got. Oh. Okay, so something's not quite right. Let's see if we can lock it down. So this corner and the back edge didn't get it for some reason. They didn't get the chamfer. Let's get some measurements on here and see. When you think you get it right, gotta go ahead and mess it up. We were roomies during BCT. Oh, Kim? It's gotta be. I mean, that was the only roomie I had. Dang, dude, that has been over 10 years. That's nuts. Long time no see. Thanks for checking out this stream here. So we're getting 0.746. So our Z height's not exactly right. But I think it's within our spec. 0.75, so all dimensions are within 5 thou, so we got to be within 0.745 and 0.755. Oh. Literally 0.7455. Hey, thanks, man. I appreciate it. I looked better last year. I lost like 70 pounds in 2020, and then I gained it all back when I went back in the office. So interesting that the Z is not quite right. So we must have not quite measured off the parallels. I'm getting 0.7465 on this one. 0.746. So on the back side, it's good. It should be good all over. 745. That's technically in spec. Okay. And this is 4.001, so we're within 1.5 thou. I should hold this where you can see it. We're in 1.5 thou on our length. That's pretty sweet. I can't say it's good enough. I need to finish up that I need to get those edges of the chamfer. So yeah, always struggling with the weight. Early morning swims and missing urinalysis. Passing people when we're setting up the urinalysis. See that you're obviously not going to the bathroom. And then you go. some running across the terrazzo to come get you. Okay. So, good news is, it should be easy to fix. Like it, but, I'm gonna touch our Z. I always used to have to wake you up. Do it this morning. Okay, so again, we're gonna try to do this without doing the first. I'm gonna try. I'm gonna more accurately tell it where it is. Actually, is this? This is actually going to be our model. So we'll only have to take 100 off of this. Get it wobbling. Oh, holy shit, that's too bad. Oh, take out to 4,000? That's a problem. Alright, type in. Okay, it says it's at 1,500 this time, and I have to believe it. Uh, okay, so this is X. It's 100. Back it up. Okay, yeah, that says exactly 100,000. So my mic is acting up. Okay. Thanks. I don't know what to do about that. Okay, and this is going to be positive. Stop that. Find it out. Put our chamfer and start at one. No prep. Three selected. Good. Probably won't take anything off this edge or the next edge. Hopefully, if we do this right, it will. Oh, come on. Sorry about that. Okay, for whatever reason, I don't think it's hitting that side either. So I'm just gonna cheat. And I'm just gonna flip it around so it hits the sides that it's actually hitting. Kind of fake it till we make it here, huh? Not that that's usually ever a good strategy. So we need to get our locations again. Bear with me. Okay, put 1500, enter, forward. So I still don't have a good explanation for why it's not getting that one side. Make it wobble. Okay, let's call that negative 100. Come up, over, back, down, make it wobble. That was quick. Okay. Well, that makes sense. That's indicated still at 0.1001 because that's the non-movable side of our jaw. So I could have saved some time there and only indicated X. Which is why if we had a stop, you wouldn't even have to do this step. But remind me to do that for the next part if you watch that one, the Titan 2M. Let's go to G30. Okay, this is going to be the last time I attempt it unless I terribly mess something up, and then who knows. So we'll do the same thing. We'll start at that line 49. Cycle start. Tool length's good. Don't need coolant. I'm going to leave the feeds. I fairly well trust it at this point. What? So okay, check out what happened, but if this doesn't work, we'll have to do some research offline. Because we seem to try both ways that I thought would fix it there. Okay. So, there is a noticeable chamfer on every side now, but it's not super even, but it is there. It's visible. You can see it, probably not on the webcam, but every edge does have a chamfer. So, with that, I think we're going to call it quits on that for tonight. That's the Titan 1M from Titans of CNC Academy. You can go ahead and check them out. Just Google Titans of CNC if you want to learn how to start machining, how to use G-code, how to basically learn this trade from the ground up. I'm not affiliated with them in any way. This is their content. I mean, it's their intellectual property. I'm just sharing it. So yeah, I hope you guys had fun. I had fun. Maybe sometime later this week, I can get around to doing the Titan 2M, which is similar. It's a little larger. I think it's a 5-inch part. Got larger holes in it, but nothing too crazy. It's still first op and then decking off the second op and chamfering the sides. So maybe we can fix the chamfer issue on that one. Yeah. But anyways, thanks for watching. Hope you guys enjoyed it. If you want to, subscribe, leave comments, hit the like button, all that typical YouTube stuff. I appreciate you guys coming out to watch this, and we'll see you at the next one. Thanks.